Okay, good day. My name is John Gogo, master student in advanced computer science, and today I will be briefly presenting on the BayMotorSystem software prototype. So I'll just give a brief overview of this prototype. Yeah, so this presentation will actually cover the system goals, the design principles, the implementation, the testing results, and all of that. So let's just dive right into the introduction. So what is this BayMotor system software? Yeah. So this BayMotor system is actually a console-based application that replaces manual garage workflows. It replaces it with automated processes. So its key features include the customer and vehicle registration. Yeah, it also includes the task assignments given to mechanics because definitely tasks will be given to mechanics, and the customer notification using the observer pattern, which I'm still going to talk about. So the primary goal of this was actually to create a modular, scalable, and maintainable system using the object-oriented programming principle. Yeah. So going over to the main components. So the main components of this motor system are the mechanic, task, vehicle, and customer. So now this BayMotor system, as you can see, it's it's actually at the center of all of this. So this system was developed for Bay Motors as a whole, which we all know it's a garage service provider, and the key requirements actually include the ability to register both registered and unregistered customers. It actually has the ability to manage vehicle details and assign tasks to mechanics. Yeah, and also managers can also post promotions for registered customers to encourage bonuses and special offers, and also to encourage loyalty. So this system actually it does not actually managers cannot post promotion to unregistered customers. So which it actually helps the company in in terms of advertisement. So if you are registered, fine, you will get those promotional offers. But if you're not registered, you're definitely not going to get it. So this system actually encourages loyalty to registered customers. So these requirements form the foundation for the system's functionality. Now, moving over to the class diagram. So this class diagram actually illustrates the core structure of this BayMotor system. So uh, this BayMotor system actually has subclasses. Yeah. So but this BayMotor system class, the class itself, it manages customers, vehicles, and tags. Now, customers are divided into registered and unregistered customers, so which are the subclasses, as you can see. So vehicles, so these are the registered and unregistered customers, as you can see from my screen. Now, vehicles are also linked to tasks, which are also assigned to mechanics. So this design uses inheritance, ensuring flexibility and extensibility. So now we're going to go ahead to polymorphism. So now polymorphism, uh, polymorphism is actually one of the um, the things that plays a key role. It plays a key role in this BayMotor system. Now, the task class is actually an abstract class, as you can see on my screen, and it actually provides a common interface with the execute method. I'm going to be showing you some of the how it's going to interact um, with this execute method with some of the subclasses. Yeah. So the subclasses in this polymorphism also include the repair task and the maintenance class, the maintenance task, which overrides execute method for different behavior. So I'm going to be going over to the code to show you the subclasses, the repair task, and the maintenance class. And I'm also going to be showing you the execute method in those classes. So for the repair task, let's quickly go over to the repair task. So that is the execute method there. And let me take you to the maintenance class. That is the execute method there. So that actually shows how polymorphism has played a key role in this system. Yeah. Then we're going to design pattern. Yeah, we're going to design pattern. Um, Design pattern actually involves three different patterns, which are the singleton pattern, the factory pattern, and the observer pattern. So now this singleton pattern, um, it actually ensures that only one instance of BayMotor is actually in the system. Now, this particular singleton pattern, it prevents duplicate systems. As you can see from the main class. So this is the main class. Yeah. So this is the main class. The singleton pattern um, actually um, it actually ensures that only it doesn't allow duplicate systems. That's that's what's going to that's what's happening inside this class, as you can see. Okay, so going back to my presentation, yeah, going to also the factory pattern. So now this factory pattern actually creates customers as either registered or unregistered. Thereby, it simplifies the object creation logic. So I'm going to be showing you the customer factory class so that you see what I'm talking about in the factory pattern. Yeah, so the customer factory class. So there you go. So this is the customer factory class. Now, going over to the observer pattern. So this observer pattern actually it is responsible for notifying the customers when their tasks are complete. So this particular one actually notifies customers when their vehicles are ready. Okay, so we're going over to the exception handling. So now this exception handling, it was actually made robust to ensure system reliability. For example, I'm going to show you in the code the invalid exception. I'm going to show you the invalid vehicle exception class. Yeah. Now look at the invalid vehicle exception class. So this class, this system actually helps so that when a vehicle number or a particular information is invalid, it ensures that it does not crash the system. So that is why it was built to be kind of robust to ensure the system's reliability. So that's what the exception handling is all about. And you might also see in the task already complete exception class. Okay, cool. So this is the class already. Okay, look at it. So it actually that's where the exception handling was actually came into play, so that the system is robust enough and does not crash. So now we are going straight into the testing results. Yeah. So now this system was tested. Actually, yeah, it was tested using the JUnit 5 um, it was actually tested using JUnit 5. Yeah. So it actually focuses on the customer registration, the vehicle addition, the task completion, and exception handling. So as a matter of fact, all tests passed successfully. Validating this actually validates that the system handles both the normal and edge case scenarios very, very effectively. But later on, I'm going to explain the few challenges that I came across in the course of the build up to this. Yeah. So um, so let me go straight to my code so that you'll be able to see um, how I tested it. Okay, so now, so this code simply shows the vehicle, the main menu. You can actually register your customer. You can add vehicle. You can assign task. You can execute task, and you can exit the program. Sure, you can exit the program. So if you want to register a customer, you can just press one. So it tells you to enter the customer name. So if the customer name is John Gogo, contact info, yeah, in case your work is done and you need to come and pick it up, and also to ensure you receive some notifications. So 919-756-400 the contact info. Now it's actually asking, is this a registered customer? So that they will, so that, because already we need to know if this customer is registered or not, so that there's some privileges, there's some benefits that a registered customer has over the unregistered customer. So if I say the customer is registered, I put yes. So if you want to enter the membership number, you can put 0001. Okay, so now it shows that, look at, the registered customer has been added, John Gogo. That is it. It has been added. So you can just play around it as you feel, as you wish. Um, you can also add the vehicle. Okay, let's add the vehicle. Now it asks you to enter the license plate. You can put USB 400 UI. That can probably be the license plate. You can enter the vehicle model. Can be a Toyota model. You can enter the owner name, John Gogo. So all these are just to, okay. So now I think it will be added. Yeah. So um, yeah, vehicle added, and look at the yeah. So these are the details: the license plate, the model, and the owner name. So the vehicle has been added. That's what it's showing. So if you want to execute tasks, probably maintenance or repairs, you can you can do that. Um, yeah, you can do that. So let's go back to the presentation. So now I'm going to be talking about the challenges. Yeah, little challenges, that we face. So this project actually provided valuable insights into practical applications of object-oriented programming principles and design patterns. And now the observer pattern posed some challenges during implementation, as it is required careful synchronization and some other things. So exception handling also was a little bit of a challenge for edge cases. Also needed some precise logic and so on and so forth. Um, so these are my references. Then concluding on this BayMotor system. So in conclusion, this system successfully automates garage workflows with modular, scalable design, and key features, which include customer and vehicle registration, tax management, and robust exception handling. Yeah, so that the system avoids some kind of crash and all of that. So with this, um, I think we have come to the brief presentation, and I hope this helps. Thank you very much, and have a nice day.